Okay, so we are back here to look at the first derivative test. We had just kind of sorted out what was happening with our first derivative and how that would affect the shape of a graph and how the values of the derivative tie into that. So if our derivative value is positive, then the function is increasing. If our derivative value is negative, the function is decreasing. And if the derivative is 0 or the derivative is undefined, then that's not increase or decrease. We call that a critical point, and it's just kind of its own little thing, not increasing or decreasing there. Okay, so we can look at that with the first derivative test here, and this focuses in on those critical points. So at a critical point C, if you're looking at your number values for the derivative, and that derivative changes from positive to negative as you pass through the critical point, then that critical point C is going to be a maximum of some sort on your graph. Okay, or for your function values, you can also think of it that way. So the derivative changing from positive to negative here. Positive indicates an interval of increase, and then negative indicates decrease. So your function values are going up, and then you hit your critical point, and then it switches to negative, decreasing, so your function values go down. And so you can see that that makes the critical point there kind of at the top of a little hill. And we can see that that's going to be a maximum, at least a local maximum, maybe also an absolute maximum, depending on your function or if you're looking at a certain interval of values. But yeah, that is what we're looking at here, changing from positive to negative gives you a maximum. So that's, if you're looking at the values, you would see a shift. The numbers are positive and then they turn negative. You can also find that on your graph. Seeing here, like the green tangent lines have positive slopes, so positive first derivative. The orange ones are negative tangent slopes, so negative first derivative. So a place where we change from positive to negative is right here at this critical point, A. Okay. So we can also see on that little graph that f of A is a local maximum for the function. It's f of A is higher than anything in its little neighborhood. So yeah, f of A is a local maximum, and we can get that from our first derivative test. All right, and so in that first derivative test, the next part kind of flips this around, and if your derivative values change from negative to positive, okay, at a critical point, oops, let's see if I can spell positive, there we go. So if you switch from negative to positive, so you're like negative coming into the critical point, you hit your critical point and then it's positive after that, that means you're going from an interval with decrease, then you hit your critical point and then you go increase out of it. So negative, hit the critical point, and then positive derivative values. That would make your critical point down at the bottom of the valley there, a minimum. Okay, and so we can see one of those on our little graph as well here. Again, the negative derivative values are right in here with those negative tangent slopes. Then the positive derivative values, positive tangent slopes, are right over here. Okay, and so we can see that there at our critical point with B, f of B is a local minimum. So that works with the first derivative test as well. Okay, so f of B is a local minimum. All right. And then our last case scenario here in the first derivative test, if f prime of x doesn't change its sign. So doesn't change sign. That means it was positive and it stays positive, or it was negative and then it stays negative. Then C, we don't really get anything special for that. It's not a maximum or a minimum, really. So C is neither a max nor a min. Okay, so yeah, you just don't get the special point from that necessarily. So let's see, to kind of graph this out, a positive first derivative might be something like this, and then let's say we level out to our critical points, okay, kind of a horizontal tangent line there. But then if your derivative doesn't change the sign of its values and still stays positive, that means there's more increasing after your critical point. So it might look something like that, because there's positive tangent line slopes here, positive derivative values, and the tangent line slopes are still positive over here. Okay, so there was no real shift in the sign. And you can see that that critical point in here is not a maximum or a minimum. It kind of looks like a max from one side, like if you were only focusing on this half of the graph. But then if you focus on the other part, then it looks like a minimum. So it's neither a maximum nor a minimum. All right, same thing if you've got negative derivative values. If you start out with like negative, level out to your critical points, and then keep going negative, it might look something like that. So negative derivative values, more negative derivative values, tangent line slopes. You can see that that's the same scenario, just kind of reversed around there. Our critical point is not a maximum or a minimum. Looks like a minimum from one direction, looks like a maximum from the other direction. So can't be both at the same time, so it's neither. All right. So that's the idea of the first derivative test.